This is part 5 of our video on Introduction to Vectors. We ran out of time in the last one, so I needed to start one last video in order to be able to finish off this last question. So we are trying to find the magnitude and direction of these vectors. We've done A and B, and we are now looking at vector C. So I could make a triangle and use Pythagorean theorem and SOHCAHTOA again, but there is another method I can use for calculating length. So back in grade 10, you should have learned a formula called the distance formula. So the distance formula says that if you do the square root of x2 minus x1 squared plus y2 minus y1 squared, that will give you the distance between 2 points. So you might not remember that formula, but it was something that we learned back in grade 10. So you are always welcome to use Pythagorean theorem to calculate the length, but you can also use the distance formula. And I will say that moving forward, especially in the next unit on algebraic vectors, we use that distance formula a lot more often. So we're going to see if we can calculate the magnitude using the formula instead of using Pythagorean theorem. So you'll notice for this one, it uses coordinates instead of the side lengths. So I do have this on an XY axis. So I'm going to try to find the coordinates of the two endpoints here. So this point is 2, 4, 6, 8. This is 9 and 3. So this is the point 9 and 3. And this is 10, 11, 12, 13, 14. And we're at what? 3, 4, 5, 6, 7, 8, 9. This is 10. So this is the point 14 and 10. So I've got 9 and 3 and 14 and 10. I am going to write those points down over here so that I can see them. So I have, let's do the tail first. I have 14 and 10. And then I have 9 and 3. So those are my 2 points. One of these is point 1. One of them is point 2. It is entirely up to you what you want to pick. But every point has its own x and y value. So x would be 14, y would be 10, x is 9, and then the y part is 3. And then you get to pick which one you want to be point 1 and which one you want to be point 2. It doesn't matter. It'll all work out in the end. So I think because I put it on the top, I'm going to let this be 1 and this be 2. Well, we could swap them, and as long as you're consistent, it doesn't really matter. Okay, so I'm going to calculate the magnitude of C. So I'm going to write vector C, and we're going to put those magnitude lines or the absolute value lines on either side. And it is the square root of x2, so I chose that to be 9. Take away x1, which is 14, and then squared, plus y2 is 3, y1 is 10, so 3 take away 10, squared. All right. So I'm going to do a little calculating. I'm going to do 9 take away 14, and then I'm going to square that. So 9 take away 14 is -5, and then if I square that, I get 25, plus, all right, 3 take away 10 is -7, and then if I square that, I get 49, and then 25 plus 49 is 74, so C, magnitude of C is the square root of 74. Now that is a decimal, and I would like to try to keep it as an exact value. I would be interested in making it a mixed radical if I can. So thinking about 74, I know that it divides by 2, so I'm wondering if it might divide by 4. That's a perfect square that's even, and it didn't. So I don't think any of the even numbers, so that would be 4, 36, 64, I don't think any of those are going to work. I could try 3 squared, which is 9. And that didn't work either. So I'm a little skeptical here Okay, when I divided 74 by 2, I got 37, which I know is a prime number. So I don't think there's a perfect square that goes into that. So I'm just going to leave that as the square root of 74. And then I need to do the direction. Now, unfortunately, we are going to just have to calculate the direction using the same method we did before, using a little bit of a triangle. So I am going to look at my vector, find the tail, right, where the vector started, and draw myself in a little fake XY axis there to help me. So I either need to find the angle on this side and do west and south, or I need to find the angle down here and do south and then west. So I think I might do this way. I'm going to make a little triangle. It seems like a waste that we use the length formula and then we still had to do the triangle to be able to count out our angle. So this is 1, 2, 3, 4, 5 units this way. And this is 1, 2, 3, 4, 5, 6, 7 units that way. All right, if I'm trying to find this angle up at the top, this is the opposite, this is the adjacent, which means tan would be a good angle to use. So I'm going to say tan of angle X is opposite over adjacent. So tan of our angle is 5 over 7. And then we're going to do the inverse tan of 5 over 7. Make sure your calculator is in degrees. So 5 divided by 7, and then inverse tan. And I get 35.54 degrees. And that angle was this one here. So this is going to be south, and then we're turning towards the west. So south, 35.54 degrees west. So my overall vector here, vector C, I don't really have a lot of space, is the square root of 74 units. And then it is going south, 35.54 degrees west. Okay, so it is up to you. If you like Pythagorean theorem, use Pythagorean theorem. If you want to use the distance formula, use the distance formula. It is entirely up to you. All right, have fun with the homework. Have a good day.